Welcome to today's lesson. I'm going to discuss the devices that we use to connect computers and other resources in a local area network. We'll begin with a repeater. A repeater is a device that receives a signal and regenerates it before passing it on to the next host. Now, repeaters operate in the physical layer. If you can remember, we have the 7 layers of the OSI model, and the lowest being the physical layer that deals with the binary digits. As it passes on the data or the signals, it uses bits, binary digits. During implementation of the repeaters, we normally do 4 repeater rule, which means that you don't need to connect more than 4 repeaters between 2 hosts, because then that increases the latency. That's a diagram showing what a repeater does: receiving a weak signal from one segment, regenerating it, and sending it to the next segment. The next device we're going to talk about is the hubs. These are actually multi-port repeaters because a repeater has only 2 ports. But for the hubs, you can have 4 ports hub, we have 8 ports and 16 ports and so forth. Now, when you connect the devices to the hub, you actually create what we call a star topology. And as you can see from this diagram, you have a number of computers connected to a hub. However, hubs operates in the physical layer, meaning that they deal with bits. They don't make any decision. Every signal that is received in one port is sent to all the other ports except the port that the signal came through. So it doesn't keep any table, any routing table or switching table. A bridge, on the other hand, is more intelligent. It actually logically separates network segments within the same network. So if you have one network and you want to create 2 different networks from the same network, then you can use a bridge. A bridge operates in the second layer of the OSI model, which we call the data link layer. It actually makes intelligent decisions on whether to pass the signal to the next segment or not. So the bridge operates or receives what we call a frame. A frame is a data structure that has data, and also it has the MAC addresses of the sender and the receiver. So the bridge receives a frame on the network. The destination MAC address is looked up in the bridge table to determine whether to filter, flood, or copy the frame onto another segment. If the destination MAC address is not in the bridge table, which we call switching table, it will flood that frame, meaning that all the other ports, the other network will be able to receive that frame. The next device, these are devices which are most common in every network. We have what we call switches. A switch is a multi-port bridge. Remember, a bridge had only 2 ports, the receiving port and the sending port. For the switches, they have several ports. We have 4 ports, 8 ports, 16 ports, all the way to 256, 10, 24 ports, and so forth. Switches keep what we call switching tables. They use MAC addresses, so that in the switching table we have MAC addresses of all the hosts connected to the switch. For example, in this diagram here, we have a number of computers connected to a switch. That switch creates a table with MAC addresses and the interfaces and even the timing. So switches also make intelligent decisions before forwarding the frames. The other device that we are going to talk about is a router, or some people call them router. So routers are devices that operate in the network layer. They deal with packets and not frames. They are basically used to connect the local area networks to the wide area networks or to logically subdivide a network. They use IP addresses in identifying the source and the destination. Routers exchange routing information through different protocols which use different algorithms. Using those algorithms, they can be able to determine the best route on which to pass the packets. They forward traffic if information on the destination is available. Otherwise, if not, they are discarded. That's a diagram that is showing a router that connects one local area network to wide area network. So you can be able to have routers, several routers, depending on your capacity. Lastly, we have the wireless access point. This is a device that is used to extend the local area network through a wireless media. An access point is installed to act as a bridge between the wired network and the wireless. So you connect this access point to a local area network, and then you use it to broadcast to other devices which are connected to the network as shown in this diagram. And that is the end. Thank you for listening.